Hi, everybody. We're doing 3.5. That's chapter 3, section 5. And this is called additional integration techniques. And right now, for this part, we're going to do something called integration by parts. Now, integration by parts, I'm going to show you the fancy formula right here. And it may not make a lot of sense to you, but I'm going to show you how it works. So let me just make it nice and big so you can see it. And this is the formula for integration by parts. The integral, if you have an integral that's in the form, the integral of u dv, that is equal to uv minus the integral of v du. Now, this may look like total gobbledygook to you right now, but I'm going to explain exactly what it means. And to do that, I'm going to show you some examples. That's the easiest way to really learn this, understand it. And I'm going to switch. I'm going to switch screens now. So let's go here. So IBP stands for integration by parts. So let's do a problem here. Let's do the integral of x times e to the x dx. Now we're gonna look at we're gonna call u and dv. So I'm gonna call. Now this is a little bit of a judgment. You got to kind of figure out what works, but in this case it's gonna be pretty straightforward. I'm gonna let this part here e to the x dx. I'm gonna let that equal dv. And this part here, the x, that's going to be my u. So if u is equal to x, then du is equal to dx. And if dv is equal to e to the x dx. Now, but where did I get this? Because the derivative of u, the derivative of x is just 1. So du, yeah, du dx equals 1, du equals dx. That's pretty straightforward. Now here, v is really going to be the integral, the antiderivative of e to the x. That's just e to the x. So therefore, this integral is equal to, I have to put my equal sign a little lower to fit underneath here. This integral is equal to uv, which is x e to the x, u and v, x e to the x, minus the integral of v, which is e to the x, du, v du, but du is dx, so it's just dx. Now, this is really what I wanted to accomplish. I took an integral that I had no way how to solve. I had no idea how to solve this. And now I have just a plain, oh, and of course, there's going to be a plus c here. But I took this has been integrated. Now I just have to integrate this part, but this is an easy integral to integrate. That's the whole point. We took an integral that was hard to integrate, and we now transformed it into something that's easy to integrate. So this is just going to be, oh, you know what? I put in the plus c too soon. It doesn't matter. Equals x e to the x minus e to the x plus c. And that's it. If you want to be fancy, you could write x minus 1 e to the x. That's fine. Doesn't matter. Either way is correct. That's correct, and that's correct. Either way is perfectly fine and perfectly correct. Let's do one of my all-time favorites. Let's do the integral of ln x dx. And we're going to let u what we're going to do is we're going to let u equal ln x, and then dv is just going to equal dx. This is going to come out very nice. So if u equals ln x, then du equals 1 over x dx. And if dv equals dx, then v equals x. And again, I'm just differentiate whatever. So this is equal to uv, which is x ln x, x ln x, minus the integral of v du, which is x over x dx, which is just 1, which is minus the integral of just dx, and that's just going to be x plus c. So it's x ln x minus x plus c. And again, if you want to be fancy, feel free to write x times ln x minus 1. That's a very lovely thing to do. But either way is fine. That's correct, and that's correct. They're both correct. You know, you can factor or not factor. It's the same thing either way. All right. Well, this is a beautiful, fabulous method. Let's check this. Let's check this one. Let's check both of them actually. We're down here, so let's check this guy right now. Let's take the derivative of. Well, I have it. I'll just do the one that's on the bottom. It doesn't matter. So this is going to be my f, and this is going to be my g. So f prime g is just going to be 1 times ln x minus x plus f times g prime. And g prime is just going to be 1 over x because the derivative of -1 is 0. So this is just equal to ln x minus 1 plus 1, which is equals ln x, which is exactly what I wanted. I wanted to get it to equal that right there. Let's go back to the one up here. Did I get I got the whole picture, right? You got the whole thing? Now let's go to here. Let's look at this. Let's make that our f. We'll make that our g. So f prime g, again, this is a check now. We're checking the answer. F prime is just 1, so it's just g e to the x, and then plus the integral of plus fg prime. Now f is x minus 1 times g prime, which is just, again, e to the x. Let's just distribute now. This is e to the x plus x e to the x minus e to the x. The plus and minus cancel, and I have x e to the x, and that's my check. And we're very happy. That was my check right down there. So this checked out. I got the original integral, and this checked out. Oops, oh, I just messed it up. Whatever, it checked out, and I got the original. Oh, technically that's called the integrand or something like that. I was never into big fancy words, but that's the story. Okay, let's do another problem. This has been loads of fun. So here we have the integral from 1 to 4 of 6x squared times ln x dx. So I'm going to let u equal ln x, which is a very safe choice because now I just have to take the derivative. The derivative is just 1 over x dx. If I made dv equal to ln x, I would have to take the integral of ln. The integral of ln is, that's all, as you saw before, that was the whole pain. So anyway, and plus this is now dv equals 6x squared. dv equals 6x squared and dx. So v, again, that's just the antiderivative. That's going to be 6x cubed over 3, which is just 2x cubed. Okay, so this is now going to equal. Well, I notice that between my u and my dv, I covered everything because that's my u right there. That's u, and dv is the 6x squared and the dx. So that's really, I need my u and my dv to cover everything in the original integral. And now that's going to equal uv, which is 6, which is 2x to the third, times ln x. Now, since this is evaluated between 1 and 4, I have to evaluate this guy between 1 and 4. And minus the integral evaluated from 1 and 4. That 1 and 4 just sticks with us the whole way through, of v du. Now, v du is 2x cubed over x dx, which is very nice because that's just the integral from 1 to 4 of 2x squared. And that's just going to be 2/3 x cubed. But again, evaluated from 1 to 4. So my final answer is going to be 2x cubed ln x evaluated from 1 to 4 minus 2/3. So this is going to be my final answer, except I have to this is going to kind of be the final answer, except now we have to plug it in. And this is going to be wow, just well, ln of, I'll tell you one thing. When x equals 1, ln of 1 is 0. So that's going to be nice. This is going to be 2 times, what's 4 to the third power is 64. So that's 128. 128 times ln 4 minus, I'm not going to bother minus ln 1, that's just, and minus 0, let's just say minus 0, minus 2/3 64 minus 2/3 of just 1. That's lovely, which is 2/3 times 63, actually, which is minus 2/3 times 63. That's 42, if I'm not mistaken. It's 21, right, 42. So this is going to be 128 ln 4 minus 42. And that is, you can crunch it out with a calculator. This is going to be approximate. This is going to be approximately what I just worked it on my calculator a second ago. 130. Oh darn! I worked on my calculator. I got to try it again. Give me. Let's see. Ln of 4. 4 ln of 4 times 128. 128. And then minus 42. Minus 42 is 135.40. 135.4. So it's approximately 135.4. But I'm happy if you just say this. Either way, it's been loads of fun. I want to give one last what do you call it, example for this this video. This is actually this video is actually part 1 for the section, but I'm gonna let u equal x. So du equals dx. That was easy enough. And dv is going to equal 5x plus 1 to the 19th power dx. So v is going to be let's see, 5x plus 1 to the 20th power over 20, but because of that 5, I have to put a 1/5 over here. So this now is equal to uv, which is Now, even though this is hideous and horrible, it doesn't matter. I'm just gonna write UV. I don't care. It's integrated, so that's our answer. So it's gonna be x times 5x plus 1 to the 20th power over 100. 5 times 20 is 100, minus the integral of, well, let's bring out the 100th, 100, 1 over 100 times 5x plus 1 to the 20th power dx. And I'm going to use, well, technically, I'm going to use u substitution. It's kind of the same thing I did over here. But all the u substitution is going to do is going to give me a 1/5. It's going to give me that 1/5 there. So this is really just minus 100th times 1/5 because of and times 5x plus 1 to the 21st power over 21. So this becomes, let's just put this all together. This becomes x times 5x plus 1 to the 20th power over 100 minus, let's see, 10500 minus 5x plus 1 to the 21st power over 2100 times 5 is 1, 2100 is 10,000, 0. So that's 10,500. And that's my final answer. See how much fun that was? Okay, everybody, that concludes part 1 of the video in the section. And it's been loads of fun, and we'll see you guys next time. Bye.